I've done an Olympiad and I got gold medal.
Okay, that sounds really good. Anyone else here who has some experience?
I also have some experience.
Okay.
I do have some experiences.
Okay, that's awesome. Very nice. So let's do some. We just heard about number theory, and I think you know the other parts of mathematics which are important. For example, geometry is important. Combinatorics, that is, counting problems are important. Algebra is important. Algebra, and of course, number theory itself is important. So these are the four main topics that you should be focusing on as far as mathematical Olympiads are concerned. And since you are in 7th to 8th grade, I'm assuming that's the grade you are in right now. Um, the only math Olympiad, the real math Olympiad for Indians, if you are an Indian, if you are an Indian citizen, then the only thing that you should be concerned about is IOQM. All other mathematical, so-called mathematical Olympiads are totally unimportant and waste of your time. And for other students who are in, let's say, in UK, UKMT is important. In United States, American math competition is important. Of course, you can you can take American math competition from India as well. So that's the basic background of what you should be taking. The other Olympiads, you can simply skip them because they have neither any value nor any good problems. You should focus on only these. There are some other contests which have some good problems, like NMTC or University of Waterloo contests. Those are have good problems, but you should mainly focus on these. Okay. So today we will be discussing some algebra, and we will be learning something really, really interesting using something very simple. Something very simple. So, can any of you tell me what is a positive number times a positive number? With the raising
That it will be positive.
with the raising of hand, please. So I see Kumar has raised hand. Okay, Kumar, tell me what you have in mind.
Sir, so I think it's going to be a positive number.
It is a
As
positive number. Very good. Positive times positive is
so, two
also
numbers with the same signs are always positive, and with different signs are always negative.
okay. So this is a very fundamental fact from the world of numbers. This is a fundamental fact. Fundamental property of numbers. So what we are going to do is we are going to use this property. We are going to use this property and create something totally new. Okay, let's see how we can do that. So if so suppose we have two numbers, a and b, whose product is 1. Suppose we have two numbers, a and b, whose product is 1. Now our goal is to show that their sum will always be greater than or equal to 2. If the product of two numbers is 1, we would like to show that their sum will always be greater than or equal to 2. So can any of you give me two numbers whose product is 1? Give me two numbers whose product is 1. with the raising of hand, give me two numbers whose product is 1. Okay, Selva Kumar, go ahead.
Yes, sir. My name is Satya Prakash, sir. I'm
Okay,
using my
Satya,
dad's
go ahead.
account.
Yes.
And one and one are two numbers, sir.
1 and 1. Okay. Okay, that's definitely right. Product of 1 and 1 is 1.
2 and 0.5.
Okay, 2 and 0.5 is also 1. In each of these cases, you can check that 1 plus 1 is 2 and 2 plus 0.5 is greater than 2, which is 2.5. So our goal is to show that this product, if it is 1, then the sum is always greater than 2, greater than or equal to 2. So how are we going to do that? How are we going to solve this? And you will see that we will be using a beautiful piece of reasoning to do this. Now, the reasoning goes like this. There are two cases. The first case, the case 1, is both numbers are 1. Just like Saket told us, A is 1 and B is 1. In that case, if both numbers are 1, then in that case their sum is 2. So that satisfies this goal. The second case is A is not 1. So if A, one of the numbers is not 1, can the other number be 1? Can any of you tell me that? Is it possible that the other number is 1?
Sir, because it will end up being some other number.
Oh, Satya, okay. Yeah, sorry, Akshita, go ahead.
So it won't be 1 because any number multiplied by 1 ends up being the same number. So it won't end up being 1.
It won't end up being 1. That is absolutely right. So if A is not 1, then B is also not 1. So the first case is that both numbers are 1. The first case is that both numbers are 1. And the second case is neither number is 1. Neither number is 1. So if neither number is 1, then what can you say? Can anyone tell me, if none of the two numbers is 1, then what can you say about these numbers? Okay, Atrey, what do you think?
Sir, A can be any number and B has to be the reciprocal of that number.
Okay, so A can be any number and B can be the reciprocal of that number. All right, that's one way of saying it. Any other idea? Kumar, Oni, go ahead.
Sir, my name is Divya, and I
Divya, okay.
think I think what we could label is that times B have to equal to 1. So and they have to be over 2. So I think any two numbers which multiply to 1 are usually greater than 2 because or equal to 2, because I don't think there's any set of numbers which multiply to 1 and are greater than.
Okay, but what in this case what we want is to know that if both of the numbers are not 1 but their product is 1, then what can we say about the numbers? Okay, Satya, what do you think?
Yes, sir. I think uh, one number should be greater than 1 and the other less than 1.
Excellent. That's exactly what I wanted to hear. Very nice work, Satya. So what
Thank you, sir.
Satya is saying is that if none of them is 1, If both the numbers are not 1, then exactly one of them is greater than 1 and the other one is smaller than 1. Why is that? Why can't both numbers be greater than 1? Can anyone tell me that? Why can't,
Because
yeah, go ahead, Akshita.
then the product will also be greater than 1.
Exactly. If both numbers are greater than 1, then the product will also be greater than 1. If both numbers are greater than 1, then the product of the numbers is also greater than 1. Why can't both the numbers be smaller than 1? Why can't both the numbers be smaller than 1? Can anyone tell me that? I see Akshita and Satya has raised hand, but if someone else can answer, why can, okay, Atrey, go ahead.
So then the product will also be less than 1.
Exactly. So if both the numbers are less than 1, then the product will also be less than 1. The product will also be less than 1. So we conclude that exactly one of them is greater than 1 and the other one is smaller than 1. So at this point, we will say something like this: without loss of generality, this is, you can write it down. This is used by mathematicians all the time, that when they're trying to solve a problem, they will choose one of the cases and solve it, and provided that choice does not affect the problem. So what is the choice that we are making? We are making a choice that A is greater than 1 and B is less than 1. This is the choice that we are making. A is greater than 1 and B is less than 1. It doesn't change anything about the problem. The only other case would be B is greater than 1 and A is less than 1, but that wouldn't change anything, because that would just, we have to use the same procedure one more time. Okay, so we have reached this far. From here we can say A minus 1 is positive. A minus 1 is positive. Why? Can anyone tell me why that is true? Why is A minus 1 positive? Okay, Papita, go ahead. Why do you think that is
My
true?
name is Kaushik actually.
Kaushik, okay.
Because A is greater than 1, sir. So if you subtract 1, it should be a minimal of 1, sir.
Right. Since A is greater than 1, A minus 1 must be positive. That's correct. Okay. Can any of you create another positive number using this process and one of the inequalities that we have here? Using the same process, can you create another positive number? Satya has a raised hand, but it would be great if someone else can also tell me the answer.
I didn't understand your question.
So my question is this: we know that A minus 1 is positive, right? We know this
Yeah.
because we assume that A is greater than 1, right? Can you create another positive quantity just like this? Can you create another positive quantity just like this? Okay. Mayuk Chatterjee, go ahead.
B plus 1.
Sorry?
B plus 1.
Okay, B plus 1 will be positive, but I'm actually looking for something else. Anyone else? Any other number that is positive that you can create with 1 and the letters that we have here? A minus 1 is positive. Anything else that you can create that is also positive? Okay, I see SJ. Go ahead. What is your name?
Uh, Yes, sir. My actual name is Angad,
Angad. Okay.
and yeah, A minus B is positive.
That is actually right. A is greater than 1, B is less than 1. So A minus B will be positive. But I'm still looking for something else. Can anyone tell me that? Akshita, what do you think?
A plus 1.
No, that's not what I want. Satya, go ahead.
Minus B plus 1.
Minus B plus 1. Okay, that's actually right. So 1 minus B is positive. 1 minus B is positive. Can anyone tell me why 1 minus B is positive? Can anyone tell me why 1 minus B is positive? Okay. Divya, go ahead. Divya, go ahead.
Sir, so minus b, it would actually, since it's a negative number, it would become minus b, and that would turn into positive. And
No,
if
we're not
it's
doing minus B. We're just doing minus B. Okay. Anyone else?
and it would
Akshita,
be
okay, Akshita, could you tell me why 1
So
minus
because
B is positive?
yes, sir. Because if we write it in the form of like B is a negative number. So
B is not a negative number. B is a positive number. B is a positive number.
but so B is less than 1, right?
B is less than 1. That is correct.
So uh, it might be 0 also. So it can be 0 or negative. So if it's negative, then
B is not 0. A and B both are positive numbers. Yes.
oh,
B cannot be 0. It cannot be multiplied by anything to be turned to 1.
That is also correct. So why is 1 minus B positive? Why is 1 minus B positive?
Because B is less than 1.
Exactly. B is smaller than 1. That's what we have assumed, right? Smaller than 1. So if you subtract from 1 something smaller than 1, then of course you'll get something positive. Do all of you understand what I'm saying? From
yes.
1, if you subtract something smaller than 1, then definitely you will get something positive. Okay, so we are almost there. Now you have two quantities. One is a minus 1, which is positive, and one is 1 minus b, which is also positive. So what can you do with both of these things? Given that I started with this thing, positive number times positive number is positive quantity. So you have two positive quantities, a minus 1 and 1 minus b. What can you do with them? What can you do with them? Okay, Akshita has a raised hand. Go ahead, Akshita. What do you think?
So as positive number multiplied by positive number is positive.
Uh-huh.
So if a minus 1 is positive and 1 minus b is positive, so the product of both numbers will be positive.
Product of them is positive. Positive means it's greater than 0, right? Product of a minus 1 and 1 minus b is greater than 0. So I want all of you to actually multiply this out, like algebraically multiply this out, and give me the final expression. Give it a try, all of you. I'll give you a couple of minutes time. Multiply this out, multiply this out, multiply this out, and expand it, and give me the final expression that you get. I'll come to you guys. I'll just give you a minute to try this on your own. I'll give you a minute to try this on your own. I see many raised hands. Vibhor Jindal, Mayuk Chatterjee, Selva Kazatia, Akshita, Pushparam. I see several raised hands, but I want all of you to try this. If you multiply it out, what do you get? Okay, Vibhor Jindal, tell me what you get.
Get A minus AB minus 1 plus B.
A minus AB minus 1 plus B is greater than 0. That is correct. So, what is the next step? What can we write next? Remember our goal. Don't forget our goal. Our goal is to show A plus B is greater than 2. So, that's our goal. So, how can we go from here to here? Think about it. How can we go from here to here? I'll give you a couple of minutes time to think about this and then tell me. Okay, Pushparam, tell me what you have in mind.
So we have to subtract A, B, and 1.
Okay. Rajiv Kumar is saying something in the chat. He's
So
saying,
can I?
yeah, 1 second. He's saying that A plus B is greater than 1 plus AB. And then he's using the fact that A times B is 1. That was the starting point of all of this discussion, right? A times B is 1. That's the starting point. So he's using it. Very nice, Rajiv. Excellent. So A plus B is greater than 1 plus 1, that is 2. A plus B is greater than 1 plus 1, that is 2. AB is 1, so I just replaced it by 1. You see how beautiful this is. We proved, and this is very important, this is how you actually write down a proof, that we proved that if product of two positive numbers is 1, then their sum is greater than or equal to 2. We proved this fact using a very simple property of number. And what is that property of number? Can anyone tell me what property of numbers we used?
The positive number multiplied by positive number is positive.
Excellent. We just used positive times positive is positive. That's all we used to prove this. Now, using this fact, we can actually show a very powerful inequality. Maybe you have heard about inequalities. Let me write that. Some of you have been studying this in Math Olympiad programs in Chinta or somewhere else. Inequality is a very important part of mathematics and algebra. And one of the most interesting inequalities that is out there is known as arithmetic mean, geometric mean inequality. Geometric mean inequality. So what is arithmetic mean?
The average.
Arithmetic mean is just the average. So if you have two numbers, A and B, positive numbers, remember we are only working with positive numbers. So if you have two numbers, A and B, then their average is the arithmetic mean. And if you multiply them and take the square root, This is the geometric mean. This quantity is known as the arithmetic mean, and this is known as the geometric mean. And the inequality says that the arithmetic mean is always greater than the geometric mean, greater than or equal to the geometric mean. Arithmetic mean is always greater than or equal to the geometric mean. That is the contention. Okay? Do all of you understand what I'm saying? Okay, now the question is, how do we show this? How do we prove this? I'm saying this over and over again. The stage of mathematics that you guys are in, 7th and 8th graders, it's very important that you begin to write mathematics and you write proofs. Because until and unless you do that, you will not be able to learn the real thing that's going on. So it's very important that you are able to write it. Okay. So now let me write this clearly, and maybe you can tell me how we can prove this. So G, the number G is known, suppose that's the geometric mean. So that's equal to square root of AB. So can anyone tell me what is G square?
G square will be A into B.
Excuse me, sir.
Yes.
I actually studied this somewhere, sir. One second, sir. Can I bring the proof?
Okay, let's wait. Yeah, someone told me what is G square. Who said that?
Sir, A into B. Sir,
That
A
is
into B.
correct. A into B. Very good. So now what I'm going to do is I'll be dividing both sides by G square. So I have 1 equals to A times B divided by G square. Remember, we have the thing that we proved a little while earlier. What did we prove? Can anyone remind me what we proved?
That
If a little while earlier we proved something. What did we prove?
so A into B divided by G square is 1. So A into B will be equal to G square, right?
That is what is true, but we proved something.
If AB is 1, then A plus B should be greater than or equal to 2.
Okay, that's correct. We proved that if product of two numbers is 1, then their sum is greater than or equal to 2. We proved that, right?
Yeah.
Okay, so now can you use this to show that G at A plus B by 2 is greater than or equal to G? Can you use this to prove that A plus B by 2 is greater than or equal to G? Can you show that? I'll give you a minute time, because that's what we want to show, right? A plus B by 2 is greater than or equal to G. G is square root of AB. I'll give you a minute time to think about this and tell me. We are very close. You will have to just do something with this thing.
So how do we know that A into B will be 1?
Actually, that AB and this AB is different. Someone else. So you have to first find two numbers whose product is 1. Can you find two numbers whose product is 1 from this equation? Find me two numbers whose product is 1.
A into B and 1 by G square.
Okay, A into B is one number and 1 by G square is another number. That's definitely, that works. But I want something else. Think a little bit more. Be clever about it. Can you give me two numbers whose product is 1 from this equation? Look at this equation and try to be a bit clever about it and tell me two numbers whose product is 1 given this equation.
Sir, is it A by G times B by G?
Excellent, excellent. Abhinandan. I think this is Abhinandan, right? Or
Sir, Abhigyan.
Abhigyan. Okay, Abhigyan is one of our students. So Abhigyan, you were right. 1 is equal to A by G times B by G. This is a very clever way of writing this equation, of rewriting this equation. We have G square in the middle, in the denominator. We can write it as G times G and then separate it out, right? So we have two numbers whose product is 1. What can we say about these two numbers? What can we say about these two numbers? Their product is 1. What can we say about them? Yes, go ahead, Mayuk.
Sir,
Their
the
sum is greater
sum
than
should be greater than 2.
The sum will be greater than 2. Excellent. So sum A by G plus B by G will be greater than or equal to 2. So we are almost done. Just take G as LCM. So A plus B by G is greater than or equal to 2. Now if you just cross multiply, you get the final answer. A plus B by 2 is greater than or equal to G. And what was G? G is the geometric mean, which is square root of A times B. And that is the end of the proof. And we found what is popularly known as the arithmetic mean and geometric mean inequality for two numbers. Now, what did we use? What did we use to prove all of these things? We use a very simple thing. Can anyone tell me what we used? We only used something very simple. What did we use to prove all of these things?
That a positive number multiplied by a positive number is positive.
Absolutely. Excellent. That's what we used. So what we used is we started with positive times positive is positive, and we ended with the arithmetic mean, geometric mean inequality. And we did not use anything fancy. We kept it really simple. But step by step, we built it so that we can reach this particular final result. And what is the arithmetic mean, geometric mean inequality? It's sum of the arithmetic mean is always greater than or equal to the geometric mean of two positive numbers. Okay, so it's very important that you understand this particular flavor of mathematics, that you can start with some very simple building blocks, you can work your way upward, and you can create something very powerful. This is called deductive reasoning. If any of you have read Sherlock Holmes, the detective stories of Sherlock Holmes, then the first chapter of one of the books of Sherlock Holmes was the deductive science, the science of deduction. Maybe you remember it. So mathematics is actually the science of deduction. So anyway, now I will at this particular stage, I will suggest a couple of books to all of you, and then I will take questions from the audience. Okay, if you have any questions. So the first book that I will say, so I told this at the very beginning of the class, that the only Olympiad that you should be focusing on is IOQM and American Math Competition 8, or if you have qualified 8, then AMC 10. And if you are in Britain, you can also do UKMT. These are the only things that you should be worried about. All the other Olympiads are not useful. And you should be doing it because of the love for mathematics, not just to crack a particular contest. At this stage of life, you should be just doing this thing for the love of the subject. Now, I strongly suggest that you focus on one or two books and nothing else. There are a lot of books out there. Many of them are really good, but you should not spend a lot of time browsing this book, that website. No, don't do it. Focus on two books. So I'll suggest the two books. This is the first one is Math Circles by Foreman. If you are just starting out with this journey, and if you have completed this book, then you can go ahead and take Challenges and Thrills of Pre-College Mathematics. What I strongly suggest is that you complete these books cover to cover. That's the keyword, cover to cover. Every problem, every chapter, you complete these two books before going into something else. And if you are an internal student of Chinta, of course, you should be doing all the classes, because there are problem lists and so on they are using. So you should be taking the problem solving classes regularly. Okay, now I will let people ask. If any parent or student has any question, please raise your hand and I'll be able to answer your questions. Please raise your hand if you have any questions regarding any of these things. Okay, if no question is there, then thank you for joining in today. We have
Excuse me, sir.
Yes, go ahead.
Will you be sharing this PDF where you taught?
If you are in one of the WhatsApp groups, definitely we can share it there. Yes.
Good evening, sir.
Yes.
Yeah, I'm Angad's mother here. This is the first time I got this link from a cousin of mine.
Okay.
And we are attending for the first time. So we would like to know more about what are the programs that you have, and how can he join, or do you have any assessment before he joins?
Yeah, I mean, there is a trial class that you
Okay.
can take if you want. I'm putting the name of the website in the chat.
Okay.
Go there and attend the trial class. The admin will be able to tell you more about the programs that we have.
Okay. And all these are online?
Everything is online, yes.
Right. Thank you.
Yeah, sure. Anyone else has any question?
Also, I have one more query. Sorry.
Yeah, sure. No problem.
This is non-routine maths, what they call, or this is what is there in the CBSE curriculum which helps them in 8th standard?
No, this is non-routine. Basically, the students who are preparing for the mathematical Olympiads, they are interested to do this type of problems.
Okay.
And the problems are distinguished in nature, in the sense that they are not repetitive. So if you start with the problem, and usually what happens is, in traditional textbooks, you have a formula and you have a bunch of problems repeating the formula.
Right.
But we do not encourage that. In fact, none of the mathematical Olympiad trainers do. What instead you can do is try distinguished problems, different problems.
Okay.
Maybe one or two problems every day that can take a lot of time, but that is the way to go. Okay, the problem
Okay.
that I have suggested also contains a lot of those problems.
Okay. Okay.
Okay.
Thank you so much.
Yeah, sure. Any other question, anyone? Okay, so I'm assuming not. Thank you all for joining in today. I will see you next time in another seminar. Okay, all right, bye.
Yes, sir.
Thank you, sir.